The Blue Ridge Mountains and the Great Smoky Mountains are unique in the world. It's not just because of the region's incredible biodiversity. More than 700 varieties of trees and plants live in what scientists call a temperate rainforest. It's also not just because of the age of the mountains. They are roughly 400 million years old. It's because scientists have recently discovered that, at a time when the rest of the planet is getting hotter, global warming hasn't really arrived here.
This is an unusual area because the Southern Appalachians is one of the few areas in the world that has experienced very little or no warming yet. You know, if you go to New Jersey or Vermont, you know, the air there, the temperatures there have gone up, you know, some almost 1 or 2 degrees. But here, it has not changed yet. So we still have an opportunity to get baseline data so that if warming does occur, and it's thought that it eventually will, we can at least say, here's what it was like in the early 21st century, and then keep following it and say, okay, it's changed this much.
That's right. While the Intergovernmental Panel on Climate Change reports the Earth has warmed roughly 1.5 degrees from 1880 to 2012, the temperature of the southern Appalachians has stayed essentially the same. Scientists believe elevation, geography, air currents, and the region's large number of trees all combine to affect the climate and hold off the rise in temperature. But more data is needed to understand the phenomenon. And that's where this 110-foot tower, perched atop a mountain near Appalachian State University in Boone, comes in handy.
Kind of the primary focus, besides the aerosol research, is kind of get a nice climatological background and kind of get a basis and an understanding of the local meteorology and climate.
The multiple instruments at the top of the tower record such things as temperature, wind speed, air particles, carbon dioxide, and ozone. While some of the sensors record data, other instruments collect air samples, which are piped into this small, technology-packed building at the base of the tower. It is loud inside, filled with the sounds of pumps and the whir of computer fans.
The collective purpose of this set of instruments is to monitor the effects of aerosols, haze, dust, smoke, on the solar radiation budget, which in turn governs weather and climate.
Take a look at the mountains again. Scientists want to find out if the blue haze that is so well known for enveloping the mountains is affecting the climate and helping to hold global warming at bay. It turns out much of the haze is natural. That's because trees, especially conifers, emit what are called volatile organic compounds. The region's warm temperatures increase the amount of those compounds that are released, and those compounds react with the atmosphere and form particles, which block sunlight. Scientists also want to know the effects on the climate when man-made pollution mixes with those naturally occurring compounds.
This group of instruments, this one right here, counts the particles. It uses a laser to count the number of particles in a flow stream coming into the instrument, and it measures the number of particles per cubic centimeter. This measures the amount of light that gets absorbed in the visible region by the aerosols, so how good they are at absorbing sunlight. And these two instruments called nephelometers, these foiled instruments, measure the amount of light that gets scattered by the aerosols.
This instrument gets the CO2, and this one gets the ozone from a line on the tower outside. We can read the CO2. Right now it's reading 390, and it's a little lower. You say, well, why isn't it 400? Well, it's still green outside, and the sun is out today, and the plants are photosynthesizing, and they're taking the CO2 out of the atmosphere. So they actually can lower the CO2 concentration. If you come back here in the middle of the night, it would be higher, because then all the plants are respiring because they're not doing photosynthesis, and they add CO2 back to the atmosphere. So we monitor it on a 24-hour basis and 7 days a week, all through the season. If we were to come here in the winter, we would see it center more on 400 or so because it's colder and there's less activity. And then in the summer, you see these big swings. During the day, it goes down when they're photosynthesizing, and then during night, it goes back up.
Scientists say long-term data collection of weather and atmospheric conditions is the key to answering the area's climate change questions. It's the only way trends can be spotted.
Well, we're curious about the weather too, but we're also curious about the climate. The weather is what we have right now. Climate is the recorded history about how things were in the past, and also, even more important, is in relation to today's climate, what's it going to be in the future?
And this is one of the region's oldest weather stations. It's located at the United States Forest Service's Bent Creek Experimental Forest near Asheville. Weather data has been collected here since 1945. Climate change wasn't a concern back then. Forest researchers were looking for information on rainfall, temperature, and soil moisture to study tree growth. All that information now is finding a new purpose.
And we can make some correlations between what we know in the past, distribution of rainfall, seasonal, and also on this diverse topography. But then more important then, with this past record, we can relate how the trees have been growing and where they are in the past, and then with some future climate models, project this in the future about a changing climate will certainly affect in some way or another some of the species on this landscape.
The quality of the air is directly related to the quality of your health. Okay, everybody has to breathe, and you want clean air. And also, we need to know what factors give rise to global warming. And if we don't have long-term monitoring, okay, then we won't have a baseline against which to say human activities are causing things to change. Because if we don't know what was there in the past, and we only look at what's here now, then how do we know how much it's changed?